Hey guys, it's Michelle and welcome to Michelle's STEM Journey. This week's problem of the week comes from the year 2022 10A problem 11 and it deals with algebra and exponents. I hope you'll enjoy this video and let's get started. The problem states, Ted mistakenly wrote 2 to the mth power times the square root of 1 over 4096 as 2 times the mth root of 1 over 4096. What is the sum of all real numbers m for which these two expressions have the same value? In this problem, we are dealing with exponents, and these two right here, these are the exponent rules that we will need in this specific problem. So the first one is a product rule, and that states a to the mth power times a to the nth power equals a to the m plus nth power. And then the second one is the fractional exponent rule, which states the mth root of a to the nth power equals a raised to the n divided by mth power. And so now that we have these rules down, we can get started with the problem. So keep in mind that the problem says these two expressions have the same value, meaning we can set these two expressions to be equal. Now that we have our equation, we can start out by simplifying. So 4096 actually equals to 2 raised to the 12th power. So we can just plug that in. Now we can get rid of the fraction. So 1 over 2 raised to the 12th power equals 2 to the negative 12th power. Now we want to get rid of the radical symbol on both sides. So we can go back to the exponent rules that we have right here. And this part we'll be using the very last one. So we can start off with the left side of the equation. And we want to get rid of the radical symbol on this one. So if you look at the rule, in the place of the n, we have negative 12. So that will be our numerator for the exponent. And then the denominator in this case is 2, because 2 is in the place of m. Because keep in mind that if we have the square root of a number, but it does not specify the index, then it will be 2. Unless, for example, on this side it has m, so the index would be m. But if it doesn't have an index, we can automatically assume that it is 2. Now we can use the first rule, the product rule, because both of all these bases are 2, so we can just add up the exponents. Now, because the bases are the same, we should set the exponents to be the same in order for this equation to be valid. And now we can just simplify this equation. So there are two ways to solve this problem. One, you can solve this quadratic formula, and that would give us m minus 3 times m minus 4 equals 0. So m would be 3, and then m would equal 4. And then you can just add these two numbers up. The second way to do this is by using the property of the roots, and that states for any two roots in a quadratic equation, x1 and x2, the sum of that equals negative b over a. And the b and a stands for the constants in the standard quadratic equation. So the standard equation is ax squared plus bx plus c equals 0. And then so looking back at our equation right here, we see that in the place of the b, we have negative 7. And then in the place of the a, we have 1. And then so plugging negative 7 and 1 into this, we see that negative b over a equals 7. And then if you add m1 and m2 up, 3 plus 4 equals 7. and this also gives us 7. So the answer is 7. As I mentioned before, both of these methods are okay, but the second one, using the property of the roots, that's going to save you a lot more time, especially when solving the quadratic equation won't be as easy as this. For example, if you're going to use the quadratic formula, that will take much longer than just plugging numbers into negative b over a. And remember, AMC is all about managing your time wisely because it's a 75-minute test and all of the questions are pretty hard. So yeah, the answer is C, 7.